We're back for day 5. Feeling good today. We're going to tackle this problem here and see how it goes. So it's day 5 coding every day. So it's January 20th, 4:08 p.m. It is a Monday today. I move back in to college tomorrow, so we'll see how that goes. All right, here we go. Restroom readout. One of the historians needs to use the bathroom. Fortunately, there's a bathroom near an unvisited location on their list, and so you're all quickly teleported directly to the lobby of the Easter Bunny headquarters. Unfortunately, Easter Bunny headquarters seems to have improved bathroom security again after your last visit. The area outside the bathroom is swarming with robots. Okay. You get the historian safely to the bathroom. To get him safely to the bathroom, you'll need to find a way to predict where the robots will be in the future. Fortunately, they all seem to be moving on the tile 4 in predictable straight lines. To make a list, you make a list, your puzzle input, of all the robots' current positions, P, and velocities V. One robot per line. For example, this robot is at position 0,4 with a velocity of 3, -3. Okay? Each robot's position is given as P equals XY, where XY represents their tile from the left wall and from the top wall when viewed from above. Okay, so the axes are a little weird here, I think. So 0, 0. So if we have like a grid, so 0, 0 is here. Oh, okay. So it's just like row 0, column 0, I guess. Oh, never mind. It's just normal. X is the number of tiles the robot is from the left wall. So this is X. Well, can you have negative position? No. So if this is the left wall, then X is, actually X would be, okay, so let's just go back to this one square. So X is this distance, and Y represents the number of tiles from the top walls when viewed from above. From the top wall. Okay, so I think it's just like rows and columns, basically. So you get the position and you get the velocity, where X and Y are given in tiles per second. Positive X means it's moving to the right, and positive Y means the robot is moving down. Yep. Okay, so it's a little different from what we're used to, because positive Y is down in this case. So velocity of Y, 1, -2. Before I read it, I'm going to guess, so this means moving 1 to the right and 2 up. Yeah, okay. The robots outside the actual bathroom are in a space which is 101 tiles wide and 103 tiles tall when viewed from above. However, in this example, the robots are in a space which is only 11 tiles wide. Okay, so the real test case is 101 by 103, but here it's just 11 by 7. The robots are good at navigating over under each other due to a combination of springs, spindle legs, and so so they can share the same tile and they don't interact. Visually, the number of robots on each tile in this example looks like this. All right. So we'd have 1 here, 12 here, or is that robot 1 and robot 2? Yeah, I think it's just 12 robots. I just sneeze. Okay, so all right, so these robots have a unique feature for maximum bathroom security. They can teleport. When a robot would run into an edge, okay, so it wraps around like Pac-Man, I'm guessing. When a robot would run to an edge, they instead teleport to the other side. Okay, so we can use mod for that. Hence is what Oh, sorry. Here's what robot P24 to -3 does for the first few seconds. So it starts at 2, 0, 1, 2, and 0, 1, 2, 3, 4. And then it goes to the right 2 and up 3. 1, 2, 3. So it should be here. Yep. And then 1, 2, 1, 2, 3. So now it'll be down here. Yep. Okay. So you have to simulate the robots for very long. Where will the robots be after 100 seconds? Oh, you don't have to. The number of robots, and this is once per second, is velocity per second here. I'm just going to assume it's per second. So you have to do this 100 times, basically. To determine the safest area, count the number. Okay, so we're going to calculate this. And then to determine the safest area, count the number of robots in each quadrant after 100 seconds. Robots that are in exactly the middle don't count as being in any quadrant. Okay, so that's why it's... so if we think about our puzzle input, 101 wide and 103 tall. So here, this would be 50. So it'd be 50 on this side, 50 on this side, and then this one doesn't count. And then this would be 51 on this side, 51 on this side, and then this one doesn't count. So each quadrant is 50 by 51 per quadrant. Okay. Okay, so once you get the quadrants, quadrants contain 1 robots, 3 robots. Oh, 4 robots. I thought that was a 12, but it's actually a 1 and 2 next to each other. Is that the same here? Yeah. Is it possible that more than 9 robots can be in the same position? I guess so, because it would mess up like this ASCII art, but if you just do it as lists, then it wouldn't really matter. Okay, so predict the motion of all the robots in your list. What will be the safety factor? Oh, okay, so you don't figure out which one's the safest, you just multiply. So like number of robots in quadrant 1 times number of robots in quadrant 2 times number of robots in quadrant 3. Okay, so essentially what you have to do is none of the robots interact with each other. So that means you can just do 1 robot at a time. So I think I just have to write a function that moves 1 robot 100 times and then do that for every robot. If the robots did interact with each other, I would move all of them like all 1 step. I wonder if part 2 is like that or something. Okay, so to move a robot, all right, and then we also probably want to parse input. So we're going to here we'll parse the inputs. Restroom readout test.in r. So let me just make sure this is working. f.read print f.read. All right, so this would be our input here for the example. So if I run this, okay, so, and then thinking on how I want to split this. So for line and f.read lines, I guess we'd want to have like robots. And then so line, we could split it by base. So I'll just do one line for now. So if I say line dot split, so if I print one split line, I closed the file already, so that's a little awkward. All right, there we go. Okay, so we separate it into v equals, so we can get rid of the first two in each one. So we can get rid of the first two. So we could say like position velocity, we'll just say PV equal to line of splits. So, okay, so we're given, let's say V equals 3, -3 with no. So if we're given this line, we probably want to split it again and then get rid of the first two characters in the first line. And then if we have a negative number, right, and it's if I just say like print int of -3, does that convert? Does that work? Like, does this count as a negative? I don't know. Okay, it does. Sweet. So thinking of just saying like f will take in like a piece, and then for each piece you want to split it. Which then returns two things. And then I don't know, like past tense of split. I'll just call it split piece. So split piece equals piece dot split. So that gives us this one, and then we want to say so what is our goal? We want p to be a tuple and velocity to be a tuple. Okay, so we'll just say p tuple. I don't think that's, I don't need that, but okay, so split piece of 0 is this. And then so we only want to start at the second character. So if I print this, and let's just say I say f of split piece. This is a list. We want to call it for each. Oh yeah, I want to map. Sorry, that's what I want to do. I want to map. I wanted to map it. And then each element to that function. So I want each element's. All right, let's just forget about this for a second. So I want to print piece. I guess it prints something. So All right, we're back. I realize I've been muted for the last 5 or so minutes, so that's definitely unfortunate. I have I have this button that's right next to backspace and delete that mutes my microphone. I don't know how to turn it off, so I have to really avoid hitting it. Okay, so anyway, so what I was saying while I was muted was, so far basically what I've done is just parse the input into a list called robots. And then I just commented here, each robot is a list that has 2 elements. So robot of 0 is its position and velocity. And then position and velocity are tuples. And I just made this little function just to help split the data. So sorry, I had to sneeze. Okay, so for each robot, and then I also made this function move robot. So it's going to take in a robot and then move it some number of steps, which in this case is always going to be 100. But, you know, I thought it would be cool to have it a variable. And then I was also thinking about making a grid. So a grid, and that's why I did these. So the grid, so grid is going to be a list of dots. So it's going to be a list of dots. Well, it's a list of dots, which is, okay, still not muted, which I want to be m columns, and then duplicate that n rows. So if I print grid, all right, so if I print grid, we are missing an indentation again. All right, so it gives me a 2D array of dots. So just to make sure, I want to print length of grid, gird, and print length of grid of 0. So this should give me 711. Sweet. All right, so that's that. So yeah, okay. So our robot, okay, so it takes in a robot. So let's get its position. So position is equal to robot of 0, and velocity is equal to robot of 1. So I guess we could just say for I in range steps. Okay, so let's practice moving it 1 step. So we have, oh, whoops. Sorry, I was looking at the other video of me talking muted. Okay, so we have a 2D array. So let's say we're at position row 3, column 2, and our velocity is let's say 5, -1. So I'm thinking instead of using a for loop, we might actually be able to just use multiplication. Because we know, let's say it was like an infinite grid or whatever. So this is row and this is column, this is row and this is column. So after 1 step, we'll be at 8, 4. So after 1 step. After 2 steps, we'll be at, we basically just apply this again. So this is defined as 3 plus 5 and 2 plus 2. So then we go to this, we add 5 again. So that would be 13, and this would be 6. And this is defined as 3 plus 5 plus 5, and this is 2 plus 2 plus 2. So in other words, it's x position, so position 0 plus velocity 0 times steps. And then the only trick is the wraparound, which in this case, I think we can just mod it by n. or m, I guess. Now if we're going negative, okay, so we're going infinite. If we have negative, so let me just do some tests here. So obviously if we have 5 mod 4, that would give us 1. So if we have negative 5 mod 4, I would like for this, so if we have, so mod is defined as, so if you have mod, if you have like A mod B, that is A, so it's A divided by B produces like a quotient remainder divisor. So if you have negative 4 over 5, or sorry, negative 5 over 4, that gives you negative 1 as your quotient, remainder negative 1 over 4. So this would give us a negative 1, which is not really what we want. Okay, it gave me 3. So I think that's like 4 minus. All right, let's think of it this way. Okay, so let's say that we have 4 spots. 1, 2, 3, 4. Let's say 0, 1, 2, 3. Okay. So if we start here and go 5 spaces to the right, we get 1, 2, 3, 4, 5. Okay, if we go, and that gives us 1. So 5. So the number of jumps divided by your board size equals your new position. Okay, so if we go 5 to the left, which would be negative 5, we get 1. That's 1. 2, 3, 4, 5. Okay, so it seems to work as we want it. So in C#, when I did this in Unity, it was giving me this. Like it would give me negative 1, but I think in Python it's like mod and remainder is different on how it handles negative numbers. But it looks like in this case it's working. So I think we can try this formula. Okay, so we'll say new position. So we'll do the x calculation and the y calculation, and it will be a tuple. Okay, so for the, actually let's just say new x and new y, and then we'll say new position equals new x, new y. Okay, so new x is equal to our x position, so p of 0, plus our v of 0 times steps, mod the number of columns, which is m. And then we have p of 1 plus v of 1 times steps, mod n. And then we'll say, and we'll just do it for one robot. So we'll say, well, I don't know how to really calculate this. I guess I could just do 2 steps and then see if it works, and then do a wraparound and see if that works. So new position. So let's just, I guess, return new position. Or we could print, so robot, is at new pause after steps. Okay. So we're going to say move robot, robots of 0. So we'll just move one robot. And this should be parentheses. Still not muted. We're doing good. Steps, we'll say 2 steps. And let's see where that goes. So we don't really care about the grid at the moment. It doesn't really affect anything. All right, so that didn't, it's because I'm exiting. All right, so let's try that again. Move robot is not defined. That makes sense. All right. Okay, so 0, 4, and 3, -3, and it's NM. So we have 7 rows and 11 columns. We start at 0, 4, so row 0, column 4, so like right here. So we start here. After one step, so after one step, we go 3 to the right and 3 up. So after one step, we'll be at 3 negative. We'll be at, so our x is 3, and then it should be 8. Wait, no, it should be 4 because there's 7. So we went 3 up from 0, which will give us 7. Okay, and then another step would give us 6. We're still within 11. And then 1, so 6, 1. Okay, it says 6, 5. It says 6, 5, guys. Could it be I'm modding by the wrong number? So the y should be modded by n, which is 7. Let me do it after one step and see where that tells us, because that's easier to pinpoint the exact problem. Okay, 3, 1. Oh, wait. Is it because the y is reversed? So I said 3, 4. Because -3 is 3 up, right? Okay, positive x means it's moving to the right, and positive y means it's moving down. So it should be, based on this, it should be 4, but it's not. So if we look at, so the x is good, so y, so position, so 4 plus velocity of 1, which is -3, times 1. So this obviously evaluates to 1. So I think with this, we actually just have to multiply it by -1 also, because then that would give us 7 mod. Well, if we multiply it by -1, then it would be 4 plus 3 equals 7. Oh, wait. Wait, it's at 0, 4. So shouldn't it mean it's... Okay. Well, wait a minute. X represents the number of tiles the robot is from the left wall. So that actually signifies columns. Y number from the top wall. So 4 from the top. So 0, 4 is actually here. So it's more traditional to XY plane. So then it would go to 3, and then up 3, so it would be 3, 1, which is what our program got us. Okay, so I think the program is correct, but my understanding of the problem was not, which is funny because I wrote the program. All right, so after 2 steps, it gives us 6, 5. So we're at 3, 1. So we move 3 over again, which gives us 6, which is still within 11. And then up 3, which gives us, so 2 from here, which gives us 5. Okay, so it looks good. So I think the program is correct, actually. So then we'll move it 100 steps and then just see where it is. 3, 5. All right. Running calculations. Yeah, that seems good. So yeah, 3, 5. All right. So so now what we want to do is do it for every robot, and also what we want to do is populate that position. So we'll say, so this also needs to take in grid, of course, and then we'll say grid of. So this is where it gets tricky. So we would say new y first and new x, because y is defined as how many from the top, which is what row it is, and x is defined as how many from the left, which is what column it is. So here we'll say plus equals 1. All right, I have an idea. If grid new y new x equals a dot, then set it to 0. New y new x, that, or I mean 1. Set it to 1 because there's one robot. Otherwise, add 1 to it. Or we, yeah. Or we could say this alternatively. Okay, so now let's print grid after doing it 1 time, and then also this needs to take in grid. Okay, so I'm passing it 2 tuples, which is not what it should be. Well, actually, it should be like that, because it's a 2D array. And I did it here as well. So there we go. And now we moved I'm seeing a lot of 1s. Why? So this function only gets called once. Okay, grid of new y. Oh, it's because it's... No, I actually don't know. So grid should be a list, right? List, and then each thing is also a list. Yeah, so it's a list of lists. That's good. Okay, so it's making all of them ones. So it moves a robot. Is this being called several times? I don't think so. So it's 0, 1, 2, 3. So it's making all of these new position. So new y is one value. So let me just print new y and print new x just to make sure it's 3, 5. Maybe I could just try that. Maybe it's like some logic there or something. Why is that happening? Okay. So it equals 1. Nope, doesn't. So let's see when these are getting called. So I suspect it's just updated 1. It happens once. So it's changing all of them. Okay, so let's print this. Let's see. It's a single dot, but it's updating all of them. There must be something obvious I'm missing. Robots of 0. I'm just going to print everything to make sure I know what it is. So robots of 0. So what's the first thing that I print? Oh. Okay, actually I don't know why I said oh like that. I don't really understand. So let's just debug everything and figure it out. Yeah, so this is a problem that I have, is sometimes I get weird errors like this and it takes me a long time to figure it out. So robots of 0 is a list. P is a tuple and V is a tuple. That's correct. Now this robot, maybe it doesn't know what grid is. Am I passing the right grid? Grid should be correct. Could it be the way I'm displaying it? Could it be something to do with copies, perhaps? That seems like what it could actually be. It could be the way that I'm making the list. Because, oh yeah, I know what it is. Okay. Alright, learn up here, guys. So, wow, this would take me forever. I did something, I had a similar error like this the other day. Okay, so this generates, so this is a list. So if I say print type of that, and then exit my program, that's type list. Whoops. That's a list. So now we're taking that list. So what is type of, is this a 2D list? Yeah, but it's a 2D list with one element. And then we're multiplying it by n. So the same way that you could have a list of one element times n, m, or like let's say if you have this times 5, that gives you a. So then we're taking that whole thing and multiplying it by n. But I think they all share the same reference or something. So if I print ID of G, so it looks like making one change changes it to all of them. I'm exiting my program. Yes, okay. So every sublist in grid has the same point in memory. So if you change one, it changes all of them, which obviously I don't want. So I think what I'm going to say instead is for n. Okay, so this is an ineffective way to make a 2D list. This is my first time making it that way. But yeah, so basically every list has the same reference. So I'm only changing it in one, but it actually changes it in all of them. So I'll just say grid is an empty list. Then I could just say like for I in range. So this is n. So for I in range n, just say row equals that. For j in range m, row dot append that. I gotta look up a like really easy way to make a 2D list. Maybe this is just how you do it. Or I wonder if I could say grid equals I for I in range n for j in range n. No, I'm not going to mess with that. Okay, so j times we're going to add to row, and then when that's done, we're going to say grid.append row. All right, now let's print grid and exit. And then let me just visualize it a little better so it's easier to see. So 7 rows and 11 columns. 1, 2, 3, 4, 5. All right, so grid is now good. So now when I print grid after here, it should only update in one position. Yes. So now it only updates in one position because everything has a different reference. And it's still the same length, it just looks smaller because it doesn't have the quotes. Okay, perfect. So I gotta change the way I'm generating a 2D list to this, I suppose. Okay, so that looks good. So now I want to, for robots in robots, I would like to move robot of robot. 100 steps and pass it the grid. And then this appears to be my final answer. So if it tells me here, is that what it's, it might tell me down here. Okay, 100 seconds. So 2, 1, 1, 1, 1, 1, 1, 2. All right, this looks good. So I'm going to get rid of all these print statements. Okay, because I knew I was just changing it in one location. I thought what was happening was I was changing it several times, but I was actually changing it just once. But because they all shared the same reference, it was changing them in all of them. So I'm glad I understand that. That's the sort of bug that's really kind of tricky to catch unless you kind of know what's going on. You kind of need to know how it's working under the hood a little bit. So I'm proud that I was able to identify that, especially because I just had a take-home assessment and I had a bug similar to that, and it took it's pretty much why I didn't pass it. So I'm happy that I'm making progress in that way with 2D arrays. So, and then how do I return? Oh, there's one more part of this problem I forgot. So I have to, it shouldn't be that hard, but it's just to get the answer. So essentially, we will make another function called, what do they call it? I gotta basically split them into quadrants. So calc safety factor of the grid. That's all I need, right? Yeah. So then I can just print calc safety factor of the grid. Okay, so we can assume that the grid is now working. So this generates grid 2D array of n by n. Okay, that took me maybe 10 tries. Okay, generates 2D array of periods sized n by m. All right, and maybe there's a better way to do this. I mean, it's fine. It looks fine. Okay, so move each robot 100 steps and update grid. And then here, so I'm just going to say for I in range n, for j in range m. Then I think what I'm going to do is, so I'll call top left quadrant. I'll just give it a score. So we're going to use the multiplicative identity of 1, and then we'll just multiply that every time we encounter a, a robot. Okay, top left, top right equals 1. Top left equals 1. I might just, do that. Top left, top right. Bottom left, bottom right. Okay. Okay, so we're gonna check every space. Okay, so if, and we know that it's has to be within 0 to 50, but let's define that as, so if we have 101, we integer division it by 2, which gives us 50. So normally it would be 50 and 1/2, but we get rid of that. So while it is from 0 to m integer division 2, and from, okay, so that's m divided by 2 plus 1 to m minus 1. Oh, are we starting at 1? And was I starting at 1 over here? So if you have 101, you're going to be 50. Yeah, so it would actually be 0 to 49. So this might be minus 1. And then, so you wanted 0 to 49 indices. 50 is the one you don't count, and then 51 till m minus 1. So how do we get 51? Well, we mod it by 2 and add 1. So the exact mod by 2 we will not count. Okay, and then from here, this is going to be n, and I keep saying mod, floor division minus 1, and then don't count the middle, and then it would be n floor division 2 plus 1 until n minus 1. Okay, so we have 4 situations here. Okay, so I'll just say if I is, so I is the ends, so that would be, so every row. So that's our vertical. Okay, so if I is greater or equal to 0 and it's between, so I is less than n mod 2 minus 1. Okay, I don't think I need that. So that means it's in here. So then we know it's going to be on the bottom. Okay, so this means it's the bottom, and then top would be if I is greater than or equal to, and then I think it's equal to as well. If it's equal to, so actually what we could do to make it a little cleaner is just get rid of the equal sign and do that. Okay, so if it's greater than n floor division 2 and I is less than n minus 1, My mic's muted. Oh my god, how long has it been muted? Top left, bot left, bot right. Okay. Alright, let's see. I don't need that. I do want to print grid though. Print 4G and 4 row and grid. Print row. Okay, so how did I do it? Top left. So it really should be, so 0, 1, 2, 3, 0, 1, 2, 0, 1, 2. Okay, so this row doesn't count. So the top left should be 1, but I have it as 2. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 11. So you want to take out 5. Or do you want to take out 6? I guess you want 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. Okay. Boom. 1, 2, 3, 4, 5. Okay, so this one has 2 and this one has 1. This one has 2. So it's 2, 2, 1, 1. So I think I have it backwards. So is it, so top left should be 1. This should be, top right should be 2. Bottom left should be 2. And bottom right should be 1. So I have it flipped. So I'm going to try doing this and see if that works. Nope. Well, I guess it doesn't actually matter which one's which, but so I could just multiply these together. Wait, do I add them together or do I multiply them together? Oh, count the numbers in each quadrant. So plus equals, and these are all 0. Okay, so I actually have to add each quadrant like this. 1, 3, 4, 1. It still should be wrong though. Yeah, 1, 4, 3, 1. So top left does not contain 4. So my top left right now is actually my bottom left. And then my bottom right is actually my top right. Right? Because top right, yeah. So it looks like the top and bottom are switched. Because they say 1, 3, 4, 1. 1, 3, 4, 1. Yeah, so the top and bottom are switched. So bottom is I is greater than 0. Well, I guess 0 is actually the top of the quadrant, right? So I think it's has to do with because up is like 0 is actually up here. I have 0 down here, I think. So this is actually top left and top right. Yeah, so another thing about the 2D array that's a little confusing to me is usually I just define it in terms of row columns, but when it defines it in terms of x, y, where x is the distance from the left wall and y is the distance from the top wall, it just, that threw me off a little bit, but bot right. Okay, I'm back. So then this would be bot rights. And now this should give us 1, 3, 4, 1. All right, so let's multiply them all together. 12. All right, so now it needs to be 101, 101, and 103. So n. So wide would be m, and 103 tall. Wait, the one that was wide I had is, did I mess up these? Is that why it was messing me up? Well, I was getting the right grid. I might have flipped my grid because wide should be the number of columns. So 11 tiles wide. Oh, no, that's right. 7. Okay, so 11 tiles wide, 101 tiles wide, and 103 tiles tall. And then let me try the puzzle input. And switch this to normal. And let's see if that gives me a safety factor. 0. I mean, it seems as if there are no robots present. Oh, that's why. So that's good now, and then this, I want to put the other data back in it. Here we are. This, but we are reading from this one. So, okay, it gives me some number. It's kind of impossible to fact check it, so I guess that's the point. Alright, we got it correct. Alright, for tomorrow, I really got to make sure I don't mute my mic. Like I said, I have that key right next to my backspace and delete. The biggest thing I learned from this, well, two things really. The first was building a 2D array. You cannot do it like this, where you say this times n. So that's fine because each one of these is an immutable object. But then when you have that times m, you're duplicating a mutable object which has the same reference. So if you change one of these sublists or one of these rows, it'll change it for every row because they all have the same ID in memory. So that was a big takeaway. The other thing that was a little confusing to me that I still don't fully understand what was going on was how to programmatically represent like an XY plane. Because usually I just do row and column, but when you have like X and Y, and then also, so X is defined as this distance, and Y is defined as distance from the top, where positive is down and negative is up. That was a little confusing. But yeah, so we got it. I did try to, these problems are taking me a long time. Even though this problem, when I read it, I knew how to do it pretty fast. It takes me a long time to kind of talk it through and think about it. So I have to get faster at that. I think maybe getting faster at programming, because maybe spending less time whiteboarding, because I think I understand it pretty well. But coding it sometimes leads to a lot of difficulties that I need time for, like the 2D array problem where when I was changing one row, it changed everything. So I think getting to coding sooner would be good, because it takes me a long time. So, all right, well, that was today. So I'll see you guys tomorrow for day 6. Yeah, all right. Thanks for watching.